In this video, we want to look at translating velocity versus time graphs now to position versus time graphs. When we're looking at creating position versus time graphs, we need to find the area between the graph and the axis. When we're doing this, we can break that area into either squares or triangles, with squares having an area of base times height, and triangles be given an area of half base times height. You'll be giving a starting point on the position versus time graph, and then we will use these areas to figure out the change in position over each time frame. I think this makes the most sense if we look at an individual graph and try an example problem. So here we have a graph of velocity versus time, and we want to find the area of each of these sections. And then once we have the area of each of these sections, so for example, I'm going to draw a triangle here, a rectangle here. I'm going to find the area and work from our starting point 0, 0. So this is 2 by 4. So 2 times 4 is 8. So my first section, I'm going to go up. In 2 seconds, I'm going to go up 8. And it's going to be increasing velocity, so this will be a curve starting shallow and working its way up. In the next section, it's 4 by 1. So this is going to go up 4. So from 8, I'm going to go up 4. So now I'll be at 12. And this will be a straight line. Then in this next section, I'm going to break it into two parts, a triangle and a rectangle. The triangle is 2 by 2. So this will be half base times height, which will be a total of 2. This is 2 by 2 rectangle, so this will be 4. So my total here is 6. So I'm going to go up by 6. I was at 12. By time equals 5, I'm going to go on up to 18. The velocity is decreasing, so now I'm going to have this curve sloped down. In my next section, I have a base of 1, a height of 2. So this has 2, so from 16 is going to go, or from 18, it's going to go up 2 to 20. And that's going to be a straight line. And then in this last section, it is 1 by 2, half base times height, gives me an area of 1, so I'm going to go up to 21. And now it's going to be this curved graph. This next section, I have an area of 0. So I'm going to go over to the same point, 21, a straight line. My next section is -3 high, height, 2 base, 3 times 2, 6, times a half. So I go down 3. So I'm at 21. At time equals 10, I'll have gone down to 18. Now it's increasing in the negative direction, so I'm going to draw a curve down. This next section, it is 2 by -3, I get -6. I'm going to go down to -12, or go down 6 from 18, so I'm going to go to 12 at 12 seconds. This is going to be a straight line. My lines aren't as perfect drawing on this screen here. And then this last one is 2 by 1, so this will be -1. So it's going to go down 1 to 11 by 13, or 3 by 1, sorry. So down 1.5. So down to 10.5. This will be a curve this way because it's decreasing speed. And then from 13 to 15, I have this section that's 5 by 2, which will be going up by 5. So I'm at 10.5. By 15, I'll be at 15.5. and that will be a straight line. So that is one example, or that'll be a curved line, sorry. This is a mistake here. Should be a curved line going up this way. So that is one example of a velocity versus time converted to a position versus time.